When you take limits, the first rule of thumb is to try to plug in your value, and if you get a good answer meaning that you're not dividing by 0 for your answer, then you are all set. So let's try that with problem number 6. So I see that my x is approaching 1. So if I plug in 1, I get 1 squared plus 1 minus 2 in the numerator, 1 minus 3 in the denominator. So 1 plus 1 is 2, minus 2 is 0, so I get 0 over negative 2, which is a number. It's defined, and it is the number 0. So that is indeed the limit of this. I can't do any factoring or canceling, so I am all set with that answer. So I'm just going to restate that a little bit. So I could do some factoring. If I did factoring, would it help me? So watch what happens if I factor. So it multiplies to 2 and subtracts to 1. So I would get x plus 2, x minus 1 in the numerator over x minus 3. So doing that, does that make a difference? If I plug in 1, I still get exactly the same result. So watch what happens. I would say 1 plus 2 would be 3 from that first factor. 1 minus 1 is still going to be 0, and 1 minus 3 is still going to be negative 2. So whether I factor or if I don't factor, I still get the exact same answer, and that answer is 0. It is not undefined, so don't confuse those two. To be undefined, you'd have to divide by 0. In problem number 7, we're trying to figure out what happens to this function in the limit as x goes to 2. So the first thing we're going to do is plug in the 2. So under the radical, so I still have the radical, I'm going to have 4 times 2 squared. 2 squared is 4, so 4 times 4 is 16, plus 9 gives me radical 25. Now the question is my answer going to be 5 or plus and minus 5? So at this point, you want to take a peek at what that function looks like. So if I were to graph that function, it would look something like this, with this little flat area right around that. So as x goes to 2, what's happening is my function's approaching only positive 5. Notice that I never get down into the negative part of the y-axis. So therefore, in this situation, my answer is only 5. So you would need to think about the graph before you give an answer. It's not appropriate to leave it just as radical 25. You want to give me an answer that denotes that you understand that this particular function eliminates the negative 5 from your answer. Okay, that brings us to problem number 8. So here, if I plug in 1, I just quickly look, I know the second I plug in 1, that's going to go to 0 in the denominator, which is undefined. So I'm going to not do that. I'm going to first factor. So when I factor the top, just like I had done previously, I'm going to get x plus 2 and x minus 1 over, break this up, they're both the same, and I've discovered that I have a whole at x equals 1. So before I take the limit, I'm going to cancel this. So I'm still trying to take the limit as x goes to 1. Alright, so now I'm left with this. Limit as x goes to 1, and when I cancel out that whole, I have this expression remaining. Now, when I plug in 1, what's going to happen? Well, even if I canceled out the whole, I happen to have an asymptote also at x equals 1. So this is a non-removable discontinuity. So therefore the limit as x approaches 1, because it forces me to divide by 0, is undefined. So it does not exist. So even after factoring and canceling, I still get the result does not exist. But that doesn't mean that you shouldn't factor and cancel. You need to do that to fully evaluate this and make sure that you are removing all the removable discontinuities, which are the holes. So after doing that, I still have an asymptote, and therefore my limit as x approaches that asymptote value is going to not exist. In this last problem in this section, I see that if I take my -9 and I plug it in, I'm going to have a 0 in the denominator. So since I see that, I'm going to now try to see if I have removable discontinuities, which are holes. So to do that, I'm going to factor my numerator. So I'm still taking the limit as x approaches -9, and factoring the numerator, I get, so I want 9 and 3, so x plus 9, x minus 3 is my numerator in factored form, and then x plus 9 in the denominator. Okay, I have a removable discontinuity right here at x equals -9. So let's go ahead and we can remove that by canceling. Now let's take the limit of our function as x approaches -9. My function I'm evaluating now in this canceled form is just x minus 3. So when I plug in the -9, I get -9 minus 3, so -12. And that is my limit. So I had a removable discontinuity at x equals -9. When I removed it, that was a hole, I found that from the left and from the right, my function was approaching -12. And you can check this graphically as well.